Hello students, welcome back. So we have finally completed number systems, which is chapter 1 of your textbooks. So let us take a look at what we've done in this chapter. We will do this by revising through our summary. So what have we covered? The first thing is that we covered what really real numbers are. We had natural numbers, whole numbers, integers, rational and irrational numbers. So starting with rational numbers, they are represented by Q, the alphabet Q, and rational numbers can be written as P upon Q. So it is always in the form of a fraction P upon Q, where Q is not equal to 0. Why Q is not equal to 0? Because if Q is equal to 0, your fraction would, the answer would be infinity. But that is why, which is why Q is not equal to 0. Then irrational numbers are the complete opposite of rational numbers. So these cannot be represented in the form of P upon Q, where Q is not equal to 0. And there is not really any alphabetical representation like rational numbers. Like we have rational numbers represented by Q, you do not have anything for irrational numbers. Then finally, then the next thing that we looked at was decimal expansions. So decimal expansion of rational and irrational numbers, we concluded that decimal expansion for rational numbers would be either terminating or recurring, whereas for irrational numbers it would be non-terminating, non-recurring. So by terminating, what do we mean? By terminating, we mean that there will come a point while dividing your rational numbers that the remainder will become 0 and the quotient will therefore not increase, it will halt. And for recurring, it means that the remainder series will keep on repeating and so will the blocks in the quotient. So there will be repeating blocks of quotient and the quotient will follow a pattern. Okay. And non-terminating, non-recurring, here in irrational numbers, the decimal expansion will never terminate and it will never be recurring. You will have a series of numbers after a decimal number in the quotient, but none of them will follow a particular pattern. And then real numbers. What are real numbers made up of? Real numbers can be broadly classified into two categories, which is rational numbers and irrational numbers. So when you club all the rational numbers and irrational numbers, what you get, your output is as real numbers. So real numbers is a combination of real numbers, rational numbers and irrational numbers, and every real number can be plotted on your number line, and also every number that you plot on your number line is going to be a real number. Then we looked at operators. So what are the different operators that we have? We have subtraction, we have addition, we have multiplication and division. So when you perform these operations of these operators on your rational and irrational numbers, we will get different outputs. So let us see, when we perform these, when we use these operators with two rational numbers, the output will always be rational. If you are using it with two irrational numbers, your output could be either rational or irrational. And if you are using these operators with a combination of rational and irrational numbers, the output would always be irrational. Okay? And then there were identities. These identities are similar to the algebraic identities that we have learnt in our previous classes also. So let us take a look at this. You have under root of AB, which can be further split as root of A into root of B. And even if you have a division, so if you have a multiplication sign under this under root, you can split the terms as two under roots. Similarly for division, if you have the numerator and denominator under one single under root sign or nth root sign, you can split the numerator and denominators under separate under roots. But you cannot do this for addition and subtraction. Then you have root of A plus root of B into root of A minus root of B, which is similar to nothing but A plus B into A minus B, which is A square minus B square. But here your A square is root of A square, which is going to be A, and B square is what? Root of B square. So that is why you have A minus B. So root of A plus root of B into root of A minus root of B is going to give you A minus B. The fourth identity, you have A plus root of B into A minus root of B. Now this one is similar to the third one, except for the fact that the first terms here are the same, but they are not under root of. So this is going to be root of the square of the first term minus square of the second term. So square of the first term here is A square and square of the second term is going to be B. So A square minus B. And then finally you have A root of A plus root of B the whole square. So A plus B the whole square is nothing but A square plus 2AB plus B square. But since our terms here are in the form of roots, I am going to say root of A the whole square, which is A, plus 2 root AB plus root of B the whole square, which is B. So A plus 2 root AB plus B. And finally, this section is the final one. So, rationalizing of denominators. Rationalizing of the denominators means your denominators would be irrational and you will want to make it rational. So, how are you going to make it rational? By multiplying the rational number by its rational factor. So, if I have a number say 1 upon 2, 1 upon root 2, you see that let me write it more clearly, you have 1 upon root 2. So, you see that the denominator here is irrational. Now, in order to make it rational, you are going to multiply this entire term, multiply and divide this entire term with its rational factor. So, the rational factor of root 2 is root 2. So, I will say multiply by root 2 in the numerator and multiply by root 2 in the denominator, which is going to be root 2 upon 2. So, here our 2 in the denominator is rational. Similarly, if you have two terms in your denominator, let us say I have root of a minus root of b. So, now the rational factor of root of a minus root of b is going to be what? It is going to be the same two terms but with a different sign. So, these two are rational factors of each other. So, if you had root of, suppose you had this term, root of a plus root of b in the denominator, you would multiply it with its rational factor. So, here I am going to multiply and divide by 1 upon, root of a minus root of b, and here with root of a minus root of b. Similarly, for this first one, I am going to multiply and divide these two terms with, the numerator and denominator with the rational factor, which is root of a plus root of b and root of a plus root of b. So, what is the output that we are going to get in both of the cases? I will get root of a plus b, root of a plus root of b upon, now this is root of a minus root of b into root of a plus root of b. So, if you take a look at this one, it is going to be a minus b. So, here my denominator is rational. Similarly, here I will have root of a minus root of b upon a minus b. Again, my denominator here is rational. So, this is what I meant by rationalizing of denominators. And finally, laws of exponents that we have extended for our rational numbers as well. So, if you have a, b as positive integers greater than 0 and p, q belonging to the set of rational numbers, here are the laws of exponents. If you have a raised to p and a raised to q where the bases are the same and different exponents, then it becomes a raised to p plus q. So, common base will come once and you will add the exponents. Similarly, if you have a raised to p, the entire thing raised to q, you have a raised to pq, and a raised to p upon a raised to q will be a raised to p minus q. Here the last one is a little tricky, you have a raised to p and b raised to p. So, you see that the base here is different for both these terms, one is a and the other one is b, but you have the same exponents. So, you are going to take the base, you are going to multiply the base, so it becomes ab and you take the common exponent outside, which is p. So, finally, a raised to p into b raised to p is a into b, the entire thing raised to p. So, with this we wind up with number systems. We will look at the other chapters in the forthcoming lectures. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.